This problem is based on continuity and differentiability. Show that the function defined by g of x is equal to x minus the floor function of x is continuous at all integral points. So when I put x within square brackets, that represents the floor function. That means it indicates the greatest integer less than the value of x. Let us assume the floor function x. So this can also be represented by this symbol is equal to, that is here 5. So if it is 5 being an integer, that is equal to 5. Suppose if it is a 5.01. Now what is the floor function of 5.01? It should be indicated as 5 only. That is, it indicates the greatest integer less than the x values. Okay, so we had to consider only the limits. I mean, we have already discussed a g of n is equal to, we can replace x by n. So n minus, and for the floor function of n is equal to integer is equal to by itself, integer n. So n minus n is equal to 0. So this is point number 1. Point number 2, we have to proceed with LHS. Limit g of x with the x tends to n minus. It means, let us consider this is the integer, n is the integer. On the left, that is LHL. It can be what? That is, probably that is, we can have delta x, that is represented as h. Okay, so on the left means n minus delta x or n minus h. So n minus h on the means we already taken h is equal to the infinitesimally small difference. It can be even 0.1, 0.01, 0.001. So if it is a n minus a 0.01 means, suppose let us introduce here limit n minus h. H is the interval minus n minus h. So in n minus h, since n is much greater than h, therefore n minus h is equal to n. So this is the first part. And second part, n minus h. N minus h is very, very small. Let us consider n is equal to 5. In that case, h is very small, say about 0.01. So if it is n is equal to 5, on the left hand side I have taken delta x. So let me subtract here. So 5 minus 0.01 means 4.99. Is it not? So when I take 4.99, and what is the floor function of 4.99? We had to consider 4. Is it not? So being an integer, that is, if it is 5, the next lower integer is n minus 1, 5 minus 1, 4. And that's why we had taken n, because we had to check all the integral points, and that is why we had taken n. So what is the previous point? N minus 1. Is it not? It's obvious. So we had to consider this n minus 1 in this case. So I have considered n minus of n minus 1. Do you understand this? How I get this n minus 1? Now n minus n minus of minus plus 1. So n cancelled. So 1. So this is the LHL. Let us consider the RHL part. When you consider the RHL, when we consider the RHL, limit x tends to n plus of g of x. So n limit g of n plus h. Okay, n plus h. So h tends to 0. So in that case, let us expand it. So limit h tends to 0 for n plus h and minus the floor function of n plus h. Now let us discuss this one. So n plus h is equal to n. As I already mentioned, n is much greater than h, or h is much less than n, so it can be ignored. Why h is much less than n? Because h is infinitesimally very small difference, so it can be 0.01, something like that. So when you compare to n, 0.01 is negligible, so we are neglected in the case of n plus. So n plus h means we are taken only n. So in the first part n, that is this one. Now let us go to the second part. Second part is n plus h. What do you mean by n plus h? N plus h means probably it can be 0.01. So let me consider this 5. So 5.01. So in that case, what is the floor function of 5.01? That is 5. Okay, so similarly n plus zero point zero 0.01 means n we had to consider. So again I get n. Do you understand? Now n minus n is equal to 0. So when you observe this, LHL is equal to 1, RHL is equal to 0. So they don't coincide each other, and that is why for all integral points it is not continuous. This function is not continuous. So we had to declare very clearly like this. Do you understand?